Alright, for question 23a, we are looking about this keywords, which is geometric progressions. So we have two different sequences. The first one is the arithmetic sequence, which is talking about a common difference. And the second one, we got a common difference for the AS, common difference. So let me give you an example. So just like 1, 3, 5, 7. So each term, they're adding 2. So we call this arithmetic sequence. So if we are doing the geometric one, they will having the common ratio. So for the example, it will be 2, 4, 8, 16, 32. So you can notice that each term, it is times 2. Because their relationship is multiplication or division. So we call it geometric progression. So that's why for this pattern, we need to look for the common ratio first. So how can we get that 2? Because we are using the 4 divided by 2. You're using the term after divided the term at the first previous term. Alright, so that's why if there is the T1, T2, and T3, so we can track the common ratio should be equal to term 2 divided by term 1. So which is 5 over 4 divided by root 5 over 2. So in that case, we make use of this main fraction line to make it become a division. So we write 5 over 4 divided by square root 5 over 2. And we do the swap while we are changing the division into multiplication. We can simplify the number at the bottom with the number at the top. So we simplify the 2 and the 4. So we got 5 over 2 square root 5, which is the common ratio. So that means from term 1 to term 2, it is going to times 5 over 2 square root 5. So which means from term 2 to term 3, we are doing the same, 5 over 2 square root 5. So we can check if our common ratio is correct. So we try to use the 5 over 4 times 5 over 2 root 5. Let's see, can we get the T3? So here, we do the number at the top times the number at the top, which is 25. The number at the bottom times the number at the bottom. So we do 4 times 2, which is 8 square root 5. It seems it's not the same, right? So let's try rationalizing the denominator. Because there is a square root 5 at the denominator, so we times square root 5 over square root 5. So now at the top, we do 25 times square root 5, which is 25 square root 5. At the bottom, we do square root 5 times square root 5, which is a 5 times that 8, which is a 40. So we simplify the number without the square root. 5 times 5, 5 times 8. So it should be exactly the same at the T3 now. So that's why we can assure the common ratio is now 5 over 2 root 5. So as we are looking for the next term, which is the T4. So we are using the T3, which is 5 square root 5 over 8 times exactly the same common ratio, which is the 5 over 2 square root 5. So we do simplify, square root 5, square root 5. And then we do 5 times 5 at the top, which is 25. 8 times 2 at the bottom, which is 16. And that's it for question 23a. That should be the next term. For 23b, as we have the general term. And you're looking for the third term. So that means for the general term, which is Tn equals to 2 plus square root of 3n. Now you're looking for the third one. So you're doing T3 equals to 2 plus square root of 3 cube. Sorry, excuse me. So if we're having a cube, that means we have 3 brackets. And we should go through the first 2 verses, having a second level bracket to indicate we trying to expand these 2 brackets first. So we use the rainbow. 2 times 2, 4. 2 times square root 5, square root 3, 2 square root 3. And then the next one, square root 3 times 2, 2 square root 3. Square root 3 times square root 3, which is the 3. And then we keep the 2 plus square root 3 at the back. Before going further expansion, we simplify the second level layer, which is 4 plus 3, 7. 2 root 3 plus 2 root 3, which is 4 root 3. And then we keep the bracket 2 plus square root 3 at the back. Now we do the further simplify, rainbow again. 7 times 2, 14. 7 times root 3, 7 root 3. 4 root 3 times 2, 8 root 3. 4 root 3 times root 3. Root 3 times root 3 is a 3. Times that 4, 12. Now we simplify the like terms. We calculate the like terms. 26 plus 15 square root 3.